Hello everybody, this is lecture 6 by Mr. Amr Abdelbari from the Department of Electrical and Electronic Engineering, Nearest University. Now, we have seen before what is the electrical circuit, what is resistance, what is the Ohm law, and finally, the last lecture, we see how the resistors come in series. So we see series circuits. Now we will see the resistors in parallel. Resistors in parallel meaning that they connected to the same point as they are said to be in parallel. So this point, this point, this point, all of them parallel to each other. The positive side of all resistors connected from the one side, and the negative side is connected from one side. Okay, so this is how we see the resistors in parallel. So again, parallel circuits meaning that the fact that more than one circuit current path branch connected the common voltage source. So the current will come from this source and will dissipate it in multiple branches instead of come across one branch. Here we come across multiple branches. Okay, so if one of them is off, there is still three branches, or the other branch is working. Okay, now let's see for the voltage, the current, and the resistance, how we calculate them in the parallel circuits. The voltage across all of the parallel circuits is the same because you connect from this point and this point, which is actually the same point here, which is actually the same point because you measure the voltage across each resistance, which is the same because it's nothing happened in between. There is no resistance to dissipate some of this voltage. So this is the same voltage. So V1 equal V2 equal V3 equal Vs. Okay, so this is the voltage. For the resistance, it is the sum of the reciprocal. Okay, so you have to know each resistance and then take 1 over each resistance, and then you take the summation of all of them like this, and then 1 over this summation you take the equivalent resistance, or the total resistance of this circuit. Okay, so if you have, for example, a circuits like this one, 681.5 kilo, 2.2 kilo, then the total resistance, if you calculate it in your calculator, you will find that this is the total resistance using this equation. Okay, very easy. Now for the current, as I said before, the current here is dissipated, and as you see here, the current have two paths. What's happening for the current is divided. It is make some division. So the current for the here in this resistance is the total voltage, as it's the same VA or VS over the R1 over R2 over R3. And after you calculate each current, I1, I2, I3, you will just take the summation, so you will know what is the total power, total current, sorry. Then you want to calculate the power. It is IV or VI. Then you have the VT and you have the IT. When you calculate it, then you can calculate the total power, or you calculate individually. You have the voltage, you have the current in each individual resistance, then you can calculate it, which, and you have the resistance, of course, then you can calculate the power in each resistance, then you have summation for all of them. Okay, Kirchhoff law, current law, is say that the sum of the currents entering a node is equal to the sum of the current leaving a node. What is that meaning? This is meaning that here this is a node, What is mean by node? It is like a connected point in the circuit. So all the current that come to this node, enter this node, equal to the current that come. Uh, yes. So here we have one, here we have two, here we have three. Okay. So one is supposed to be equal I2 and I3, whatever the value. So whatever the summation of the current that come across or enter one node, it is equal to the summation of the current that leaves this node. Okay. So this again, in the previous example, the current from the source is equal to the summation of the all the branches, so you can calculate the total current. Okay. Now if there is a special case for the two parallel resistors. Two parallel resistance can be found by this equation. Again, 1 over the R1, 1 over R2, take the summation, then 1 over the total reciprocal, then you take the total resistance. Or you just multiply these by each other, and then you will have the inverse of this equation. You can come across to this equation easily. This is especially for the two resistance in parallel, two only. So if you have R1 and you have R2, you just put these values in this equation to get the total resistance. Okay. Parallel current. Now if I have a source of current and I have another one in the same circuit, what I do, I just sum all of them if they in the same direction. So this is in the same direction as this one. So you see here that this is in this direction and this is in this direction. So I get 1 and 1.5. So this is 2.5. If they are in the other side, as we see last lecture in the voltage source, you have to sum, or in the voltage source they are in series. Okay, so you take the summation if the voltage source is in series. But here I have a current source in parallel, I take the summation. This is the voltage source. Okay, sorry, maybe we can remove this. So I have here 1 and I have here 1.5, then the total is 2.5. If it is reverse, if it is this one is reversed, so this is the other side, then I have 0.5. Okay, and the resistance will be the polarities of the resistance will be in from the where the current go enter the resistance. So the current come from this side, then this is the positive, this is the negative. Okay, now the current divider, when the current enters a junction, it divides the current inversely proportional to the resistance values. What does that mean? That means, as we Kirchhoff current law, it states that the current that come or enter one node, it is divided. It is there is 3 branches, and there is in each branch different value for the resistance. There will be a different value for the current, and you can calculate it. Okay, so here this is the calculation for the two resistance equation, R1 and R2. For R1, that is the current, the portion of the current from the total current, it is R2 over over the summation, R1 and plus R2. Here it is inversely proportional. So here I2, it is equal R1. Note this is I1 and this is 1. Here it is I2. I calculate the current that come across the second resistance. I put in the nominator that's the other one. Okay, so it is reversed. Remember to see that, and multiplied by the total current. Okay, this is the total current that enter these two parallel resistors. Okay, now finally we have the power. As I said before, the total power is you sum power 1, power 2, power 3, power 4, the summation of all of them using this equation or whatever the equation for the power. This is b equal to v square over r, because here you don't have to calculate the current, you just use the total voltage over the resistance, so over the resistance of R1 or over the resistance of R2, then you take the summation. Okay, then you take the summation of all the powers dissipated in each resistance. Okay, so here he asked for the total power if 10 voltage applied to the R1 and R2, then 10 square over R1 plus 10 square over the value of 150, it is equal this value. Okay, thank you very much for listening.